In this video, we will be looking at how to find the equation of a parabola, specifically in vertex form. So as a reminder, this is vertex form, y equals a, x minus h squared plus k. As another reminder, h and k represent our vertex, and the a value represents that vertical stretch, compression, reflection that also pairs up nicely with the step pattern. Now, if I did want my equation in standard form, I could get that by expanding and simplifying. So using distributive property. Now, if I want my equation in vertex form, the first thing I have to do is identify the vertex. And if I have a graph and I can easily read off the step pattern, then I also want to identify that because that gives me my a value. So if we look at this first example, I can clearly read off my vertex. It is 1, 4, which means my vertex form is going to start y equals something for the a value, x subtract 1 squared plus 4. So the x minus 1 is going to match up with that axis of symmetry at x equals positive 1, and the plus 4 matches up with that optimal value of 4. Now for my step pattern, I really just need that first step, and when I move to the right one, I move down 1, so the a value is negative 1. And there's my vertex form. If we look at the next one, the vertex is at 3, negative 2. So our vertex form will begin with y equals something, x subtract 3 squared, and then minus 2. If I read off the first step, right 1, up 2, that will match with my a value. Now the visual approach is nice if I can clearly read off my step pattern and I can clearly read off my vertex. The step pattern can sometimes have fractions or decimals, and if that's the case, you do not know if you are getting the accurate a value just by looking at the visual. And also the visual approach is only good if you have a graph in front of you. So let's take a look at the algebraic approach. First thing, you're going to be given information about the vertex, so put it into vertex form for that h and k value. Then use another point to sub in for x and y to solve for a. So let's take a look at our first example. This parabola has a vertex at 4, negative 2, and the parabola passes through this random point 7, 1. So my vertex y equals, I don't know my a value, the axis of symmetry is positive 4, so x minus 4 to the power of 2. Make sure you include that power of 2, otherwise you won't have a parabola, you'll have a line. And then the optimal value of negative 2, so minus 2. Now I'm going to take the helper point, x is 7, y is 1. So I'm going to swap 7 for the x, 1 for the y. Everything else, copy paste. And now it's time to isolate for a. Now, please note that the a and the bracket squared are glued together by multiplication, but the minus 2 is just being subtracted. So I'm going to bring the negative 2 over to the other side. It'll turn into addition. Now inside the bracket, just going to clean up. 7 minus 4 is 3. And then in my next step, 3 squared is 9. And I like to write 9 times a instead of a times 9. And then 1 plus 2 is 3. And now for our final step, we'll divide both sides by 9. And we get a third for a. So our vertex form equation is y equals 1/3, then x minus 4 to the power of 2, subtract 2. Let's try another one. The vertex is located at negative 4, 3, and there is a 0 at negative 3. Now, I don't care about the 0 being there. It's not enough to use factored form because I don't have both zeros. Although in reality, I could find the other 0 because I know my axis of symmetry, but we are focusing on vertex form for this question. So first, the vertex is coming in. Axis of symmetry is -4, so x plus 4 squared, and then optimal value of +3. Now, this x-intercept, we need it to be a coordinate, and that is -3, 0. So x is -3, y is 0. So 0 equals a times -3 plus 4 squared plus 3. First thing, I'm going to bring that 3 over. I do not want to accidentally collect like terms with something it is not a like term with. So 0 minus 3 is -3. And then for the bracket, -3 plus 4 is 1. And 1 squared is 1. So we've actually finished isolating for a. Y equals -3 x plus 4 squared plus 3. And these are just very generic questions. Sub the vertex in, sub the point in, isolated for a, and wrote the final equation. Now, there could be questions that are slightly tweaked or word problem scenarios. So let's take a look at this next one. The zeros are located at -3 and 11, and the optimal value is -14. Determine the equation in vertex form. Now, if I didn't specify vertex form, I did have enough information to go into factored form because I have my zeros, but it did specify vertex form, which means I need the full vertex. And if I only have the optimal value, that means I'm missing the x-coordinate, and I know the y-coordinate is -14. But lucky for us, we have the zeros, and we know that the axis of symmetry is exactly halfway. So -3 plus 11 divided by 2 is going to give us 8 over 2, which is 4. So now we have a full, complete vertex. And we can start off with our vertex form. X minus 4 squared minus 14. And now when I have to pick a point to sub in, I have 2 coordinates here. Make sure you don't write those zeros as -3, 11. They are 2 separate coordinates. I can either use -3, 0, or I could use 11, 0. I'm just going to use the positive one. So I'm going to replace y with 0, x with 11, and now time to clean up. The 14, just going to kick it to the other side, it becomes positive. 11 minus 4 is 7, and 7 to the power of 2 is 49. And now I'll divide both sides by 49, and we can reduce here. Numerator and denominator can be divided by 7 to get 2 over 7 for a. And now our vertex form, y equals 2 over 7 x minus 4 squared minus 14. And this is a parabola where even if I did have the graph, I would not be able to confidently predict that the a value was 2 over 7 just by looking at the step pattern. So even if I did have the graph, I would be doing this algebraic approach. All right, first little word problem. A cotton candy vendor sells a bag of cotton candy for $1 and gets a daily profit of $100. One day he decides to sell a bag for $2 and ends up making a maximum profit of $160. Determine the equation in standard form of the parabola that represents this scenario. Now, a few things that are popping up. First of all, I see the word maximum. That's making me think that this 2 and 160 are related to maximum. But I also see that I'm giving these values, we're talking about profit, we're talking about selling price. So I'm going to start with a sketch. Now, profit depends on the selling price. So I'm going to put profit on my y-axis, and there it is. And then x is going to be my selling price. And I am given some information. When the selling price is $1, the profit is 100. That's a coordinate. When the selling price is 2, we get this maximum of 160. and this is my vertex. And then my parabola would do something like this. Now I can go down into the negatives. I can have a negative profit. I'm losing money. That doesn't really matter for when I find my equation, but just for my sketch. And now we're ready. My vertex is 2, 160, selling price, profit. So I can put that into vertex form. Now, before I do that though, I am going to write some let statements. I have a nice labels in my sketch, but I'm going to add let statements as well. So let X represent the selling price, and let P represent profit. So X is on the x-axis, P is on the y-axis. So instead of me writing y equals, I'm going to write P equals. I don't know my step pattern, so I don't know my A. And then X subtract 2 from the axis of symmetry plus 160. Now I'm going to sub in my helper point, and my helper point is this one here, which is 1, 100. The profit is 100. The selling price is 1. And now, same thing. I'm going to isolate for A, so I'm going to bring the 160 over. It moves over with subtraction, and 100 minus 160 is negative 60. And then 1 minus 2 is negative 1. And a negative to the power of 2 is going to be positive. So it's going to be positive 1. So that's my A value. And now I have a nice profit vertex form equation. Now, that's great, but the question did specify we need standard form, and this is where our distributive property skills will come back into play. Now, reminder here, an exponent of 2 does not mean you're distributing the exponent into the x and into the negative 2. It means you have to multiply the base by itself, and the base is the bracket. So your first step should be to write the x minus 2 bracket twice. And now we can go into our distributive property. Now I'm going to do the 2 binomials first and let the negative 60 relax out front. And now x times x is x squared, negative 2 times x, again, negative 2 times x again, and negative 2 times negative 2, positive 4. Close the bracket, plus the 160. Now I'm going to distribute the negative 60 into all 4 terms, and then I'll do a big collecting at the end. And we'll have negative 60x squared, positive 120x, positive 120x again, minus 240, and plus 160. And now, just for space, I'm going to head up here. The profit is negative 60x squared plus 240x, and then minus 80. And there is my standard form equation. And now, actually, with my standard form, I know that the y-intercept is at negative 80, so if they sold their cotton candy for $0, they're losing 80 bucks there. And there is finding the equation in vertex form from a word problem. Just the key here, draw a sketch first, then you can see your vertex better and you can see your helper point better. All right, final question and word problem. A golf ball is hit off a roof that is 7 meters tall. The ball reaches its maximum height of 25 meters at a horizontal distance of 90 meters from the golfer. Determine an equation in vertex form to model this scenario. All right, I see that we're dealing with height. Height is always going to go on our y-axis, and I'm not going to have negative height here. There's nothing underwater going on. And it doesn't look like we're dealing with time on the x-axis. It looks like we're dealing with this horizontal distance. So I'm just going to label it as D. Now, the golf ball is hit off of a roof that is 7 meters tall. So that's going to be my initial value, or my y-intercept. That's going to be my little helper coordinate, 0, 7. And now we're told that the maximum height is 25 meters. That is a height. So I'm going to put it on my y-axis, and apologies for my bad scale here. And the horizontal distance where this maximum occurs is at 90. So I'll put 90 there. And then there's the vertex, 90 for the horizontal distance, comma 25 for the maximum height. And now there's my parabola. So in terms of my let statements, let D represent horizontal distance in meters, and let H represent the height also in meters. So instead of y equals, we do have h on the y-axis, so h equals the a value, and then instead of x plus or minus, on the x-axis we have d, so d, and then subtract 90 from the axis of symmetry, and plus 25 from that optimal value. And now I'm going to sub in the y-intercept, so h is 7, distance is 0, and now time to clean up. I'm going to bring that 25 over to the other side. 7 subtract 25 is negative 18. And then cleaning up the bracket, 0 minus 90 is negative 90. And negative 90 to the power of 2 is 8,100 times that a. And now we'll divide both sides by 8,100. And this can be reduced. Numerator and denominator can both be divided by 18, so that we're left with negative 1 over 450. And the negative makes sense because our parabola was opening down, so that's a good sign. And I am going to keep this fraction. And there we are. There's our vertex form. No need to expand and simplify this because we weren't asked for standard form. And that's it for finding the equation in vertex form. You need to be given some sort of information about the vertex, whether you're given it directly, whether you're given the zeros and the optimal value, and you can average your zeros to get the full vertex, whether you're given a word problem where you're given information about the max or min. And then you need a helper point to sub in and finish solving for that a value. And that's it.